Alright guys, so we are starting the next section of the Q4 Week 6 exit ticket. So, let's go straight to the questions. Number 8. How would the results of chlorinating water be affected, if at all, if excess chlorine-free water was accidentally added to the water in the chlorination tanks? So I didn't read the passage, which you don't have to first, so now let's actually figure out what they're talking about. Water pumped through the ground, remove contaminants, suspended particles of organic and inorganic matter. These are the things they need to get removed. Particles are too large, so it's a filter system, so it's water, activated carbon, sand. The filter depth. So as you go down the filter, you increase the particles that are removed, and the time for filter efficiency to drop to 50% increases. Okay, so that just means it gets better as you go further down the filter. All right, chlorine, that's what we want. So the water was pumped into storage tanks and treated with various concentrations of chlorine to destroy parasites and bacteria. So let's see, as we increase the chlorine, the percent of the bacteria increases too. So if we up the chlorine, then we up the death of our bacteria. So the percentage of bacteria, so let's see. How would the results of chlorinating water be affected, if at all, if excess chlorine-free water was accidentally added to the water in the chlorination tanks? So if we decrease, that's a decrease in the chlorine. We know that if we increase chlorine, we're going to decrease the amount of bacteria. So we'll probably see an increase in bacteria because it's the opposite of what's happening right here. So the percentage of bacteria would decrease. Yeah, sweet. And it was our first answer. Nice. Okay. And that one was a tricky question because it didn't tell us where to look. So we did have to skim through all of it. So if you missed that one, it could have been a timing issue. All right, which of the following statements about pore size is consistent with the results of method 3? So I only need to look at method 3. Now, let's see what happens here. As we increase pore size, we remove less. So that's a decrease of arsenic, a decrease of copper, and a decrease of lead. So we don't want big pores. No big pores. Increasing pore size, nope. Increasing pore we don't talk about bacteria and parasites. Decreasing pore size results in an increased amount of arsenic removed. So if I get smaller with my pore size, I remove less arsenic. I'm going to go with yeah. That does happen on our table because it goes from 30 to 62 if we go in the opposite direction. So you have to pay attention to directionality. Okay, 10. Which of the following procedures would yield more information about the effects of chlorine concentration on parasites and bacteria in water? So we have parasites and bacteria, right? So the effect of chlorine on parasites and bacteria. Determining what percentage of parasites and bacteria are killed by UV light. That doesn't talk about chlorine. Determining what. So no, it doesn't mention chlorine. Determining what percentage of parasites and bacteria are killed during the process of rapid sand filtering. That also doesn't talk about chlorine, so no Cl, no Cl. Determining how the nutrient content of the water changes with chlorine concentration. Maybe, because we could figure out how the bacteria live with the nutrients. We'll see. Determining what percentages of individual types of parasites and bacteria are killed at different chlorine concentrations. Okay, so we want to know the effect of chlorine concentration in parasites. So this one is going to be a lot better because then it's actually talking about those two things. We have the parasites and we have the chlorine concentration. That's both key terms in the question. Letter H only has one key term. So that's right. All right, 11. Scientists were concerned that sediment particles contained within the rapid sand filters were contributing to the amount of particulate matter in the water. Which of the following procedures would best allow? So we think that the particles in the filter are seeping out into the water. Filtering pure water through the filter and measuring the amount of particulate matter. Yeah, because there would be no particulates in that. That sounds okay. Testing the amount of dissolved metal ion in the water before and after filtering. Well, it doesn't say anything about the particulates being metal, so I'm going to cross that one off. And adding additional sediment particles to the water before filtering. That would just give us more junk to filter. Measuring the amount of sediment in the water before and after filtering. They're already doing that. So you want to do something where we don't have any particulates, and then seeing if it gets particulates later. So A is the best answer there. I keep wanting to tell you guys what kind of questions these are, but then I told myself that after week 6 you guys had to start figuring it out using what I gave you, and it's really difficult to not just say it. Alright, overchlorinating water can result in the production of potentially harmful byproducts called trihalomethanes. If chlorine concentrations above 0.25 ppm can result in dangerous levels, which of the following chlorine concentrations should scientists recommend to best purify drinking water and bacteria? So, it would make sense if you just read the question to go here, but we want the one that's the most effective, but still under 0.25. So I'm going to go to chlorine concentration. So we can't have this one, even though it's super effective. And 0.25 is 99.99, and 0.20 is 99.9. So those are both pretty good. Now, if chlorine concentrations above 0.25 parts, have that. So it's above. It doesn't say greater than or equal to. Greater than or equal to 25 parts per million, right? Greater than, yeah. Okay. Sorry, I always got my Pac-Man confused. So it doesn't say or equal to, it just says over. So we can still use this one because that's 99.99 effective, but we definitely cannot use this little homie right here. Number 13, molecules of zinc are very close in size to molecules of copper. If the percentage of zinc ions in water also was measured before and after reverse osmosis filtration, what relationship, if any, would scientists expect to see? So, molecules of zinc are close to molecules of copper. If zinc is measured before and after, what relationship would scientists expect to see between pore size and zinc removal? So what is the copper thing? It's still, as pore size increases, this decreases. So it's, and it was like that for all of them, so we'll probably have the same relationship. So that's the opposite. As pore size increase, the percentage. That sounds pretty good to me, because that is the exact same as copper, and we don't need to read through the other choices because that's a very straightforward answer. And the last one, if a city's water contained equal amounts arsenic, copper, and lead, a reverse osmosis filter with which pore size would remove the most heavy metals? Okay, well, the best pore size across the board. Oh, wait, no. Because this one has a weird trend. So the best pore size across the board for these two would be 2. But this one is largely 3. So we're going to be between 2 and 3 here. Now, the most heavy metals, we're still going to pick 2 because that's a 2 out of 3 response. 3 would remove 1 out of 3 the best. And 2 out of 3 metals is more than 1 out of 3 metals. So your answer to 14 is F.